That was a shockwave, a supersonic, high-energy pressure, or sound wave. Did you know focused shockwaves can offer highly effective medical treatment for canine, equine, and other veterinary injuries? Here's the thing. Not all shockwaves are created equal. Electrohydraulic shockwave generators have, by far, the most evidence for clinical rehabilitative success. Shockwave devices are used medically on humans and animals for a variety of applications. For example, lithotripsy uses shockwave energy to break up solid kidney stones. In the case of PulseVet shockwave, focused energy has been clinically validated to help heal soft tissue injuries and reduce chronic pain. Its pulsed energy waves stimulate cells, triggering the release of a wide variety of growth hormones and beneficial proteins that increase blood flow, accelerate bone and tissue healing, and regulate inflammation to ultimately enhance the healing process. There are three main types of shockwave generators: electrohydraulic, used by PulseVet shockwave, piezoelectric, and electromagnetic. The original shockwave devices utilize the electrohydraulic effect, where an underwater electrode, like a car's spark plug, fires to form an explosive vapor bubble, similar to the way lightning causes thunder. A primary shockwave reaches the tissue, almost immediately followed by a more intense, focused, reflected wave. Piezoelectric and electromagnetic devices were developed to more consistently control pulses into a smaller focal volume to break up kidney stones without unnecessarily focusing energy into the surrounding kidney tissue. These generators mechanically displace fluid utilizing an aligned array of vibrating piezoelectric crystals in the piezoelectric method, or electromagnetic induction of a membrane, similar to the movement of a loudspeaker in the electromagnetic method. While these pulses are more consistent than electrohydraulic pulses, the total energy and effective focal volumes are considerably smaller. In these devices, shockwaves don't actually form until they reach a specific target area called the focal zone. This is because as the waves travel, they gradually press together to create high pressure at that precise point. As a result, there's a much lower focal volume of affected tissue. Because piezoelectric and electromagnetic shockwave devices don't generate the same intensity as electrohydraulic devices, they take longer to build up pressure, cover a considerably smaller area, and rely on focused pulses and cavitation to create a true shockwave within that smaller therapeutic area. However, because the ratio of energy to focal area, also known as energy flux density, may be the same or greater in piezoelectric than electrohydraulic, the data can be misleading. In fact, some piezoelectric generators even promote energy flux densities greater than a level that has been shown to cause tissue damage. While both piezoelectric and electromagnetic generators only deliver a single wave during each pulse, electrohydraulic generators uniquely deliver both a direct wave as well as a focused, reflected wave to the affected tissue. This unique combination may give electrohydraulic devices a more varied and stimulating effect with each pulse, while the other devices produce a more repetitive, uniform wave. Ultimately, electrohydraulic shockwave generators create a significantly different output than electromagnetic and piezoelectric generators. Clinical research shows electrohydraulic generators have, by far, the most evidence for success, despite all three methods being available for commercial use in veterinary medicine for about 20 years. When choosing shockwave for clinical use, knowing the type of generator offered is crucial. It can make all the difference in treatment outcomes for your elite performance horse, working dog, or family best friend. Results matter. Ask to see the evidence.